Okay, let's talk about the intermediate value theorem. Now, before I read the theorem to you, I want to just show you a picture. Let's actually look at, I'll just show you a picture here. Let's suppose we have this graph right here. Okay. And we know this point is, say, 1, -1. And we know this point, 1, 2, 3, 4, 1, 2, 3, 4, 5, is 4, 5. Okay. Now, we know that we have a polynomial function. It does a bunch of stuff, right? And then it goes through that, goes through that point, comes up, crosses, and then it lands up over here, and then it keeps going. Okay. I don't really want to focus on any of the other things. What I want to focus on is if you didn't know the graph, but all you knew was these 2 points, and you knew that one produced a y value that was negative, and the other one produced a y value that was positive. Polynomial functions are smooth and continuous. So if you know that it goes from below the x-axis to above the x-axis, aren't we guaranteed an x-intercept in between 1 and 4 then? And the answer is yes. Not only are we guaranteed an x-intercept, well, which is also a 0, but we are guaranteed at least 1. Who's to say it doesn't cross multiple times in that gap, right? So generically, we're going to read the intermediate value theorem. They say in the intermediate value theorem, f of a and f of b are of opposite signs. So this is a, this is b. So that means the y values, this is f of a, right? So this coordinate point is a, f of a. This coordinate point is b, f of b. So if this one is negative and this one is positive, or vice versa, then we are guaranteed at least 1, 0 in between A and B. They're calling it C. So let's read this. Let f be a polynomial function. The intermediate value theorem states if f of A and f of B are of opposite signs, one's positive, one's negative, then there exists at least one value between A and B where it equals 0. Okay, so that's it for that. Except for now we get problems like this. Show that f of x equals x cubed minus 5x squared plus 3x plus 6 has at least 1, 0 between 1 and 3. So this is our A and this is our B. So basically all I have to do is find f of 1 and f of 3. So let's find these. If I plug in a 1, I don't need red to do it. F of 1, 1 minus 5 plus 3 plus 6. Here we're going to get -4, -1, +5. Okay, f of 3, 27 minus 45 plus 9 plus 6. All right, what is this? -36, -30, -3. Okay, so since one of them produced a positive value, f of 1 is 5, f of 3 is -3, and this is a polynomial, we're guaranteed a 0 in that gap. So we can say, because f of 1 equals 5 and f of 3 equals -3 by the intermediate value theorem, and there must be at least 1 0 between, or we could say 1 0 in the interval from 1 to 3. That's an interval, not a coordinate point. All right, and that's it for the intermediate value theorem. Okay, so since we took an equation and wrote the graph, we're now going to flip that. We're going to take the graph and write the equation. Okay, so looking at this graph right here, I can see that we have an x-intercept here, here, and here. If the x-intercept goes through it, it's an odd degree. If the x-intercept is it gets just touched, then we have an even degree. Okay, so this one will be odd, this one is even, and this one is odd, right? So that means x equals -3, x equals 2, x equals 5. Okay, now I know that x equals 2 has to happen twice, right? I could have had x equals 5 happen like 3 times, say, right? But here's my trick for that. If it happens more than once, it's going to do a kind of a squiggle here rather than go through it. Oh, it's going to do kind of a squiggle rather than go through it kind of nicely. This goes through it kind of nicely. Here's what I mean by a squiggle, right? It's going to kind of curve and then jot through it. So this, I would say, is a larger odd degree. But if it goes through it kind of sort of linearly, if you zoomed in, then we're going to say that it's just one time, because that's the pattern that we've noticed. Okay, so if these are the zeros, then what are the quantities, or in other words, the factors? Well, if this produced a 0, then I'm going to add 3 on both sides. Then this was the factor that we set equal to 0, right? Same thing here. I'll subtract 2 on each side, and I have that twice. And then this one just once. Okay, so that means I have the factors x plus 3 times x minus 2, x minus 2, x minus 5. Those are the factors for this polynomial. Now, could we have a multiplier in the front here? Absolutely, we could have a number multiplier. We don't know what that is yet. I'm going to put a variable there. Okay, we're going to find it, don't worry, but I don't know what it is just yet. So first, let's look at these steps. Did we identify the x-intercepts? Yes. Did we find the factors? Yes. Did we address end behavior? Ends up, so I know that this number is going to be positive, right? And then determine multiplicity. We did that as well, right? Find the polynomial of least degree. So how many degrees do we have here? Well, how many turning points? We have 1, 2, 3 turning points. So that means degree 4, right? Now, some people look at this and go, well, it's directions, right? It's directions, Janine. Well, we have 1, 2, 3, 4 directions. So degree 4 is the lowest we could have. All right. And I have that, so I'm content with that. All right. Equals f of x. Now, the only challenge I have is that, what is that multiplier? Yes, we know it's a positive, but what is it? So we're going to pick a point on our graph. The easiest is the y-intercept, okay? Looks like 0, -2 is a point on the graph, but you could really use anything. Like if you knew any of these other points, you could use them. Can't use an intercept, but any other point. So here's what I know by that. When I plug in a 0, I have to get an answer of -2. So let's plug in 0 and see what happens. when I plug in 0 here, I have a number there. I don't know what it is. This will be a 3. This will be a -2, another -2, another -5. Okay. I need this to equal -2, right? Because when 0 goes in, -2 comes out. So when 0 goes in, -2 comes out. Okay. So this becomes -60. Holy smokes, for real? Wow. Because this is a 10 and -6, so -60. Which means then that our A value is -2 over -60. So in other words, it's 1/30th-ish. So our function is f of x equals 1/30th x plus 3, x minus 2 squared, x minus 5. I'm not going to lie, it's not my favorite looking function because of that ugly fraction in the beginning, but let's see. Let's grab our calculator. X plus 3, x minus 2 squared, and x minus 5. I'm going to say standard graph. Uh-oh. I must have an error here. My x minus 5 needs to have a power of 1. Yep. Delete that. Delete that. All right. Does that graph look like that one? Yep. Is my x-intercept, x-intercepts going through and touching at the correct spots? Yep. How about my y-intercept? 0, -2? Yep. All right. That means that we have the right function. Okay. Now we already talked about maximum and minimums in the previous video. So we're just going to kind of reiterate or re-go over extrema. Now, global maximum, global minimum, or some books use the word absolute, right? We also have local, which is just like in the neighborhood, right? So for it to be the global, it's the highest of all or the lowest of all. We don't have a global minimum because this graph continues to go down, okay? All right, but we do have local min because in the neighborhood, we do have the lowest point, meaning to the right and to the left. All right, let's do a word problem here. And it'll be our last one. An open top box is to be constructed by cutting out squares from the corners of a 14 by 20 sheet of plastic. Okay, so it's not a square. $14.20. And then folding up the sides. So we're gonna take this out, take this out, take this out, take this out, right? All right. Find the size of the squares that should be cut out to maximize volume. Okay, so we know that volume is length times width times height. Okay, so picture this. If I slice, actually like that, and like that, and like that, and like that. Okay, if I remove the corners, I'll use a small eraser. And I fold up along the red lines, these will be the sides. That's going to be the side. So that'll be the side. Oops. Side. And front. Other side of the box. And then this is the bottom. Okay. Now, Our challenge is what was the size of that square. So this square, we're going to call it an x by x square that we have to get rid of here. And then we have 4 of them. Got to get rid of all of them, right? So if I get rid of that x, and this side gets folded up, and this side gets folded up, that means that the box, the bottom of the box, is not going to be 14 units long. It's going to be the length here will be 14 minus 2x long. Okay. Now, rather than being 20 here, if I get rid of those squares on the ends and I fold it up, that means the width of the box is not going to be 20. It's going to be 20 minus 2x wide. Now, if you fold up all the sides, the height of the box is going to be that x, because that was here that you folded up. That'll represent the height then. Okay. So this is our equation. Now you could multiply it all out, and there would be nothing wrong with that. I am going to graph it. So y equals, oh no, I need to see my equation. 14 minus 2x times 20 minus 2x times x. Now I need to change my window probably pretty significantly. Yeah, that's not very helpful. Now x is the amount that we're cutting off, so I don't really need to go into negative territory. And if you think about this, my x can't exceed 10. In fact, my x can't exceed 7. So I might just go 7 there, because I only care about those portions. Now volume, let's go 400. All right, let's see what we got. Oh, I like that. So that is the window that tells us, I'll show you, I'll zoom out and show you that in a minute here, but we are looking for that highest point, right? So our graph looks something like this, and we're after this. This would be the x value, and this is the volume. So we need to find that spot. Well, we can just go calculate, second, calculate, maximum, and I have to go to my calculator, I have to go to the left of it, enter, and then to the right of it like it's asking, enter. If you want to guess, you can, enter. 2.7 and 339. 2.7 and 339. So find the size of the squares that should be cut out. Cut out a square, 2.7 by 2.7. Now these are going to be centimeters. Centimeters from the corners. And that will maximize your volume. Okay. Now I said a moment ago I would zoom out so you could see more here. Zoom out. Enter. So if I zoom out, it looks like this. But once we get past an x value of 7, I can't even make a box anymore. If you think about that, if the width of this box right here is only 14, once I get past 7, I don't have a box. So I only cared about looking at 0 to 7 for x values. Everything else is outside of, like, it's not even a consideration. So we would restrict the domain based on those facts. All right. Well, let me stop it.